Hi everyone, today we're looking at combinations of functions. We're going to add, subtract, multiply, divide different functions instead of numbers. I'm going to start off with a sum. We are going to add two different functions. They have used the f of x and g of x function. Here are those two separate functions, and it says to find f plus g of x. Then evaluate the sum when x equals 2. So let's start with our f plus g of x. I'm going to do the entire f of x function plus the entire g of x function, which it says that f of x equals 2x plus 1. Now, usually it's very helpful to use parentheses. If they're there and you didn't really need them, that's fine, but sometimes you do need them, and if they are not there, then we could get things wrong. So I'm going to use parentheses on the entire f of x function and the entire g of x function. So I did all of f of x plus all of g of x. In this case, I actually didn't really need the parentheses, so I can go ahead and get rid of those. And then I need to combine like terms. My x squared, there's actually only one of those. Plain x's, I've got a 2x and another 2x. So if I combine those, I get up to 4x. And then my positive 1 and negative 1, those add up to 0. So it looks like the f plus g of x, first of all, it is the exact same thing as saying f of x plus g of x. Those are the same thing, and we found out that it equals x squared plus 4x. Next up, it says, then evaluate the sum when x equals 2. So this means I need f plus g. It says the sum, so I did my addition, when x is 2. F plus g of 2. Now, if I did an f of 2, that would mean I sub in a 2 for the x in my f function. If I did g of 2, I would sub in a 2 into my g function. This is f plus g of 2, so I'm going to sub in a 2 into my f plus g function. So I will get 2 squared plus 4 times 2. F plus g of 2 is going to be a 4 plus 8, so 12. All right, we found the two pieces of information. Now, again, I just want to point out that there is another way to say the same thing. If I had said f of x plus g of x equals the x squared plus 4x, that is the exact same thing as what I said here. The same for f of 2 plus g of 2, that's the same as my f plus g of 2, and it still equals a 12. I'm not sure which way the book is going to note it. Maybe it'll do it back and forth. It doesn't matter. They're saying the same thing. Okay, so what we did with the sum, the addition, is going to be very similar to our difference, the subtraction. They gave us two separate f of x and g of x functions. We have to find f minus g of x. Again, that means I take my entire f of x function and I will subtract the entire g of x function. So the f of x function was 2x plus 1, and I'm going to use parentheses again, minus the entire g of x function, which is x squared plus 2x minus 1. In this case, I did need the parentheses as far as distributing to my second set of parentheses. So I would get 2x plus 1, and then minus x squared minus 2x and plus 1. Okay, so I'm going to combine my like terms. The negative x squared is on its own. I've got a 2x and a negative 2x. Those add up to 0. So I have no more x's. And then my positive 1 and another positive 1 combine to a positive 2. So it looks like our f minus g of x is the negative x squared plus 2. And again, another way to say the same thing would be f of x minus g of x is also a negative x squared plus 2. Same thing. We are now going to evaluate the difference when x equals 2. So again, I'm going to take my difference, my subtraction that we already found. We subtracted the two functions, but x is now a 2. I have negative 2 squared plus 2. This means that I have a negative 4 plus 2, so negative 2. And yet again, there's another way to say the same thing. I could say f of 2 minus g of 2, and it would still be a negative 2. All right, so we've done addition, subtraction. We are now going to do multiplication and division. Multiplication is your product of functions. Division is your quotient of functions. And so I'm going to do the f times g of x. So you can either write fg, like f times g of x like this. Or you can say the entire f of x function times the g of x function. They both mean the same thing, so I'm going to take my f of x, which is an x squared, and I'm going to multiply it by the g of x, which is x minus 3. I do have some distributing to do here. I need to distribute the x squared to each of them, so I end up with an x cubed minus 3x squared. F times g of x is x cubed minus 3x squared. Or in other words, the f of x times g of x is also x cubed minus 3x squared. And then the second thing that they have us do is to evaluate the product when x equals 4. So I've already got the product. I've already multiplied my two functions together, but they want the x to equal 4. So I will now have a 4 cubed minus 3 times 4 squared. So 64 minus 48, a 16. So f times g of 4 equals 16. I could say the same thing with f of 4 times g of 4 equals 16. All right, and last one is the quotient. You have to divide the two functions. They again gave us an f of x and a g of x function. Now note that it does say that we're not going to do this when g of x equals 0 because we cannot divide by 0. So we are going to do the entire f of x function divided by the entire g of x function. That's what we want, f over g. Our f of x function is the square root of x, and the g of x function is the square root of 4 minus x squared. I don't have much simplifying I can do here. This is pretty much as good as it's going to get. And again, they could say the same thing as f over g of x, and it's still just your f function divided by the g function. So I would get the same thing. All right, and then it says find the domain of f over g of x. All the x values that I could possibly have. I don't want to divide by 0. I also need to avoid taking the square root of a negative number. So as far as my domain, all the x values that I have, first things first, what would make my denominator 0? So let's look at the square root of 4 minus x squared. That can't be 0. So I'm going to do the same thing on both sides. I'm going to square both sides. So I get 4 minus x squared can't be 0. And then I will subtract 4 on both sides. So a negative x squared cannot be equal to a negative 4, which if I multiply by negative 1 on both sides, my positive x squared cannot equal a positive 4. Then I will square root both sides. So my x cannot be, now keep in mind we need a plus or minus when we do the square root. My x cannot be a positive or negative 2. And you can check that out. Negative 2 squared is 4. 4 minus 4 is 0. Also, positive 2 squared is 4. So those would both give me a denominator of 0, and we cannot divide by 0. As far as domain goes, I know positive and negative 2 are not in the domain. Let's also look at your square roots. We don't want to take the square root of a negative number. So let's take a look at things that make the 0. So we used a negative 2 and a positive 2. In fact, my numerator would be 0 if I just subbed in 0. So let's check out 0. These are all the things that would give us a 0 in either the numerator or the denominator. I'm going to basically test a number in each of these sections. Maybe I'll test like a negative 3 and see what I get. Square root of negative 3 over the square root of 4 minus negative 3 squared. Okay, small problem, square root of a negative at all, not going to be included, so I'm going to put an x here. That part's out. If I pick a number in this section, maybe I'll pick like negative 1. Square root of negative 1 over the square root of 4 minus negative 1 squared. Oh, small problem again. I got square root of a negative. So that is not included in our domain. Let's pick a number in this section. So maybe like a positive 1. Square root of positive 1 over the square root of 4 minus 1 squared. I get a 1 in the numerator. Good, that works. I get the square root of 4 minus 1, so 3. I don't really care how messy this number is. What I just wanted to know is if I'm taking the square root of a negative or if I have to divide by 0, and I'm not doing either of those, so this section does work. So check, that part is in my domain. And then I'm going to check this last section, something greater than 2, so I'll just pick like 3, positive 3. So square root of 3 over square root of 4 minus 3 squared. In the numerator, I got a positive under my square root. Good. In the denominator, I've got 4 minus 9, so negative 5. Oop, I have a negative under the square root, so for that reason, this section is not in my domain either. As far as the domain goes, the domain is everything in this 0 to 2 section. What I have to figure out first before I write my domain is, am I going to include the 0? Am I going to include the 2? And I kind of had over here, we already decided we can't include the positive 2 or the negative 2. So I'm not including the 2. 0, let's see. If I sub a 0 in, square root of 0 over the square root of 4 minus 0 squared, it gives me 0 divided by the square root of 4, which is just straight up 0. And that's fine. The real number, that works. So I'm going to put a square bracket to include the 0 up to the 2, which I will not include, so parentheses on the 2. As far as inequalities go, you can say the same thing with an inequality. We can say that 0 is less than or equal to, like it's included, and we're talking about domain, so I'm talking about x values. 0 is less than or equal to all the x's that are then less than 2. I did not put an equal to sign for 2 because we're not including the 2. So these are two different ways to say the same thing about domain, all the x values that we can sub into this function. All right, I hope that helped.